Welcome back. This is chemistry question 45 from IMAT 2018 past paper. So let's solve it. It says 5 atoms are shown below. The letters are not chemical symbols. Which one of the following atom has the highest first ionization energy? So before we solve this, we have to first recall the definition of first ionization energy. So it's the energy required to remove 1 mole of electron, which is mainly the valence. So the valence electron from neutral atom to form an ion. So this is the basic definition we are supposed to know before solving this question. Okay, so it explicitly also mentions that these letters are not the chemical symbol. So be careful because especially for option 8 mentions Z. So do not confuse it with saying it's zinc because for zinc it is Zn. So none of these symbols mean anything. Okay, so before we also solve this, we must know the diagram that they have represented, the display diagram of this atom that are shown. So we must know what these numbers represent. So I'll go with this Z symbol. So okay, so 23 and 11. So what does these numbers represent? So this number 23 represents atomic mass, which is basically the sum of mass of neutrons and proton, the number of them. And this number 11 represents proton number, or basically atomic number. So we know that these are atoms. These are not like ions or anything else. So since these are atoms, we know that the number of proton are equal to the number of electrons. So meaning the proton number are equal to electron number. So we'll take this 11 as the number of electron. So since the question is mainly about first ionization energy, we have to construct the electronic configuration for each of these atoms so we can identify which one most likely has the highest ionization energy. So by constructing a very basic and simple electronic configuration, so I'll show that. For first we'll go for option A, which is Z2311. And so also while we are solving this question, we'll kindly ignore atomic mass because atomic mass doesn't have any effect on the ionization energy because it's just basically the sum of neutrons and protons. So atomic mass has no influence on ionization energy whatsoever. Okay, so we'll go with option A first. So construct the simple electronic configuration, which is since it's 11 electrons, so 2, this is the innermost shell, 8, and then 1, which is the outermost, the valence electron. So it's 2, 8, 1. And for B, which is a W 20, 10. So for this, it's 2, 8. C is X 21 and 9. So this is 2, 7. So option D, which is Y 22 and 11. So its electronic configuration is also exactly the same as option A. So option E, which is V 19, 9. So this electronic configuration is also as similar to option C. So what we can also deduce from this that some of the given options, the atoms has exact same electronic configuration to each other, but they have different atomic mass, is that these atoms are actually isotopes of each other, like this the option C, which has 2 and 7 electronic configuration, and the option E also has electronic configuration same as C. They both are isotopes. So C and E are isotopes to each other. And also there's other isotope, which is option A and option D to each other. So I'm going to use different colors. So it's to each other, not to any other atoms in the option. So option A and option D are isotopes of each other. So I'm going to mention A and D are also isotopes. So as we said, the atomic mass has no influence on the first ionization energy. So why is that? Because there's only increase in mass. So ionization energy is only affected by proton number and the electron numbers. But atomic mass also includes neutrons. So there's increase in number of neutron while still being the same element. So what this means is the neutron is basically neutral atom, a neutral subatomic particle. So it has no influence on the ionization energy. So we're going to focus on the electronic configuration and the proton number. So now we know C and E and A and D are isotope to each other, their partner. So we'll consider, we'll easily cancel out option A and option, wait, sorry. So we'll easily cancel out option A and also option D, since both of them have higher number of electron shells. So what causes decrease? So first of all, we have to mention the key points that decreases ionization energy. So it's firstly, they have larger atomic radius. So this atomic radius is as a result of having high number of electron shells. So they have high number of electron shells. What this means is like 1, 2, 3. So they have 3 electron shells, whereas the other, which is B, C, and E, have only 2 electron shells. So meaning they must have higher ionization energy compared to option A and D. So that's why we cancel out option A and D. And since they're isotopes to each other, we'll consider them as just one. Like we consider them as the same element since they have same electronic configuration. And number two is they have a decrease in influence of nuclear attraction. So they have decrease in influence of effective nuclear attraction. So this is because there's more, which I'm going to mention in number 3, increase in electron repulsion, or you can call this by other name, electron shielding effect. Increase in electron repulsion effect. So these are the 3 main reasons for decrease in ionization energy. Okay, so now since we cancel out option A and D, so let's focus on C and E since they're isotopes to each other. So we are going to consider them as just one element and compare it to option B. Okay, so we're just having option B, and C and E will just consider the same thing. So you can choose anyone, whichever you like. So I'm gonna just choose option E. So the electronic configuration 1 has 2 7, which is for E, or you can choose C. Since they're isotopes, it doesn't make difference. So compare it with the option B, which is W, the atom, and their electronic configuration is 2 and 8. So since both have same electron number of shells, so the only one that has higher first ionization energy is W. So why is that? Because it has higher number of protons. So it has total of 10 protons. It has 10 protons, but but this atom E has only 9 protons. But although the atom W has more number of electrons, but still the number of electron shells are same in both. So both has 2 electron shells, but W has higher number of protons. So W has the highest first ionization energy. So the main correct answer is option B, which is W 20 and 10. Okay, so this is how we solve this question. And thank you guys for watching my video. I hope you find this video helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.